Video I'm going to talk about resistance, electrical resistance. And the symbol is capital R. Sometimes you'll see little r, but we'll talk about that later. And the units are the volt per amp, but you see that very rarely, or the ohm, which is the Greek capital letter sigma. So if we were to do an analogy with water, which we often like to do in this topic, then if we have a water pipe, then resistance can be compared to how hard it is for the water to flow through the pipe. So if we have a pipe here, a cylindrical pipe, and we have water flowing through the pipe, how hard it is for the water to flow through the pipe is like resistance in a wire. Now we come up with a definition for electrical resistance of a conductor R. That is the ratio of the potential difference across its ends to the current flowing through it. So the formula for resistance is the ratio of potential difference divided by the current. And in words, we'd write it like this. And the symbol on the circuit diagram for a resistor is a rectangle, like that, elongated rectangle. Now, if we have a wire of length L and surface area A, then there's another formula to work out the resistance, because the longer the length of wire, i.e. the longer the length of pipe, the harder it is going to be to push the current fluid through it. Therefore its resistance is proportional to length. But the narrower the pipe, the narrower the wire, then the harder it is to push the current through it as well. So resistance is inversely proportional to its cross-sectional area. So let's imagine we have a resistor whose cross-sectional surface area is big A, and whose length is capital L, and it's made up of some conductor which has a property called resistivity, which has the Greek letter rho, and we have a current passing through this of current I. And we could measure the current in the circuit using an ammeter, put the ammeter in series with the resistor, and I can measure the potential over it using a voltmeter V. And the resistance of a wire which you can investigate experimentally says that resistance is proportional to the length, and the resistance is inversely proportional to the cross-sectional area. So the resistance equals length divided by area, and the constant proportionality is the resistivity. So length, L means the length, and we measure it in meters. A is what we call the cross-sectional area. In meters squared, and rho is the resistivity, which is a property of the conductor, and it's measured in ohm meters.